roiling space.
Ever looked up at the night sky? I wondered what lurking in the darkest corners of the universe. Ready to jump into the wild world of black holes? These cosmic wonders are super mysterious and mind-bending. And trust me, you won't want to miss this. They're the ultimate cosmic monsters, invisible behemoths whose gravity is so powerful that nothing, not even light, can escape their grasp. So, what exactly is a black hole? Imagine taking something with a lot of mass, like our sun, and squishing it down into an incredibly tiny space. To really get a sense of scale, we'd have to squish the sun down into a tiny ball just a few miles wide. Can you imagine that? The gravity of this super-dense object would become so intense that it would warp the very fabric of space and time around it. That's a black hole in a nutshell! It's not an empty hole, but a huge amount of matter packed into an infinitesimally small point called a singularity. The surface of a black hole, the point of no return, is called the event horizon. Imagine standing right at the edge of a cosmic waterfall, feeling that wild energy rush. It's like the universe is alive, right? Once you cross that line, there's just no way to go back, right? It's like stepping into a whole new world where things change forever. Any light, any spaceship, any star that gets too close is pulled in, stretched into a long, thin strand in a process called spaghetti and disappears from our observable universe forever. Because no light can escape, we can't see black holes directly. They are completely, utterly black. If we can't see them, how can we even be sure they're real, right? It's like, how do we know what's out there if we can't see it, you know? Great question! We hunt for them by observing their effects on the space around them. Imagine a dancer spinning on a dark stage. You might not see the dancer, but you can see their partner being twirled around. In the same way, astronomers can see stars orbiting what looks like empty space. By measuring the star's speed and path, they can calculate the mass of its invisible partner. If that mass is huge and crammed into a tiny area, they've likely found a black hole. One more way we spot them is by checking out the chaos they stir up. When a black hole pulls in gas and dust from a nearby star, this material doesn't just fall straight in. It swirls around the black hole, forming a massive, spinning disk called an accretion disk. As the material gets closer to the event horizon, it gets superheated by friction and starts to glow incredibly brightly, emitting X-rays and other forms of radiation that our telescopes can detect. It's like a cosmic crime scene. We can't spot the culprit, but we totally see the messy evidence it leaves behind, right? Now, there are a few different types of black holes. The most common are stellar mass black holes. These are the ones that form when a massive star, much bigger than our sun, runs out of fuel. Without the outward push of nucleofusion, the star's own gravity causes it to collapse in on itself in a spectacular explosion called a supernova. What's left behind after a supernova is either a superdense neutron star or, if the original star was really massive, a mysterious black hole. How wild is that? Our Milky Way galaxy is probably home to millions of these stellar-massed black holes, silently drifting through space. Then there are the real giants of the universe, supermassive black holes. These monsters can weigh as much as millions or even billions of suns. Isn't that just wild? Scientists believe there's a supermassive black hole at the center of almost every large galaxy, including our own. At the heart of the Milky Way, about 26,000 light-years away, lies Sagittarius A*, a supermassive black hole with a mass of about 4 million suns. For a long time, its existence was just a theory. But in 2019, the Event Horizon Telescope collaboration made history by capturing the first-ever direct image of a black hole's shadow. A supermassive one in the galaxy, M87. It was an incredible achievement, turning science fiction into science fact. So what happens if you fall into a black hole? Picture this. You're on this super cool, indestructible spaceship, right? How awesome is that? As you approach, the tidal forces would become extreme. The gravitational pull on your feet would be so much stronger than the pull on your head that you'd be stretched out like spaghetti. Cross that event horizon, and suddenly, Space and time get all weird and wild. It's like everything flips upside down. The singularity is no longer a point in space ahead of you. It becomes your future. Just as you can't stop moving forward in time here on Earth, you wouldn't be able to stop moving toward the singularity inside a black hole. What really happens at the singularity? Honestly, we're totally in the dark about it. It's like a big mystery, right? Our current laws of physics break down at this point, and it remains one of the greatest unsolved mysteries in science. One of the most fascinating ideas about black holes comes from the legendary physicist Stephen Hawking. So, get this, he's saying black holes might not actually be totally black. How wild is that? Due to quantum effects near the event horizon, they can slowly leak a tiny amount of radiation, now known as Hawking radiation. This means that over an incredibly long time, longer than the current age of the universe, a black hole can slowly evaporate and eventually disappear. This concept bridges the gap between gravity and quantum mechanics, two pillars of modern physics that don't always play nicely together. Now, before you start worrying about a black hole wandering into our solar system and swallowing us up, you can relax. The nearest known black hole is still thousands of light years away, and there are none close enough to pose any threat to us. They're not just cosmic vacuum cleaners, mindlessly sucking up everything around them. You really have to get super close to one of those to feel any danger, Imagine this. If we swapped our sun with a black hole that had the same mass, Earth would keep spinning around it just like it does now. Crazy, right? It's wild to think about how gravity works. It would get super cold and dark, like really gloomy and just not fun at all. It's the kind of weather that makes you want to curl up under a blanket with hot cocoa, right? Black holes challenge our understanding of reality. They are laboratories for extreme physics, where the rules of space, time, and gravity are pushed to their absolute limits. They force us to ask fundamental questions about the nature of our universe. What's on the other side? Could they be portals to other universes? Well, these are still questions for science fiction. The real science of black holes is just as mind-blowing. Every new discovery, from gravitational waves created by merging black holes to the stunning images from the Event Horizon Telescope, brings us one step closer to understanding these enigmatic cosmic giants. They are a powerful reminder that the universe is far more strange and wonderful than we can possibly imagine. Thanks a ton for sticking with me on this crazy adventure into the abyss. If you enjoyed this deep dive into the cosmos, don't forget to hit that like button and subscribe for more adventures through space and time. Let me know in the comments what cosmic mystery you'd like us to explore next. Until then, keep looking up.
Royaline Space.